Hello children, we have studied exercise 1.1. I hope that you all have understood. Today I am going to continue exercise 1.2. In this exercise, we will study how we represent a rational number on the number line and method to find a rational number between two rational numbers. From this diagram, we get to know that rational numbers are the collection of set of natural numbers, whole numbers and integers. Now, what are rational numbers? A number is called rational if it can be expressed in the form p upon q, where p and q are integers and q is not equal to 0. For example, 1 upon 2, 4 upon 3, 5 upon 7, 1, etc. In p of 1 upon 2, here p is equals to 1 and q equals to 2. Next, 4 upon 3, here p equals to 4 and q equals to 3. Next, 5 upon 7, here p equals to 5 and q equals to 7. Next one. Now the question arises, it is not in the form of p upon q, but it is, because we can write 1 as 1 upon 1. So p is equals to 1 and q equals to 1. Every integer, natural and whole number is a rational number. All of them can be expressed as p upon q form. For example, 2 can be expressed as 2 upon 1. That's why it is a rational number. There are infinite rational numbers between two rational numbers. There are two types of rational numbers, positive rational numbers and negative rational numbers. Positive rational numbers. If both the numerator and denominator are of same signs, for example, 2 upon 3 and minus 2 upon 3. In 2 upon 3, both numerator and denominator are positive, and in 1 minus 2 upon minus 3, both numerator and denominator are negative. Second, all are greater than 0. Third, example, 12 upon 17, 9 upon 11 and 3 upon 5 are positive rational numbers. Now, negative rational numbers. If numerator and denominator are of opposite sign, for example, minus 2 upon 3 and 2 upon minus 3. In minus 2 upon 3, numerator is negative but denominator is positive, and in 2 upon minus 3, numerator is positive but denominator is negative. All are less than 0. For example, minus 2 upon 17, 9 upon minus 11 and minus 1 upon 5 are negative rational numbers. Before continue this exercise, we need to understand some important terms which you have already studied in your previous class. First, natural number. Natural numbers are also called counting numbers, which contains the set of positive integers from 1 to infinity. For example, 1, 2, 3, 4, 5, 6, 7 and so on. And second, whole number. Whole numbers are also known as natural numbers with 0. For example, 0, 1, 2, 3, 4, 5, 6, 7. Now the question arises, then what is the difference between natural and whole number? In natural number, 0 is not included, but in whole number, 0 is included. That means whole number are the collection of natural number with 0. Third, integers. Integers are defined as the set of all whole numbers with a negative set of natural numbers. For example, minus 3, minus 2, minus 1, 0, 1, 2, 3 and so on. Now let's continue our first topic, that is representation of rational numbers on the number line. As we see in the slide, number line is the collection of negative number, positive number and 0. And 0 is the mid value which separates the positive number and negative number, and it can never be negative or positive. Positive rational numbers are always represented on the right side of the 0 on the number line, and negative rational numbers are always represented on the left side of 0 on the number line. Question 1. Represent these numbers on the number line. First part, 7 upon 4. Here, two cases arises. Case first, if numerator is greater than denominator, then first convert the fraction into mixed fraction as we have done, and we get 7 upon 4 is equals to 1 whole 3 upon 4. This represent 7 upon 4 lies between 1 and 2. Now let's see on the number line. Here 4 upon 4 represent 1 and 8 upon 4 represent 2 and 7 upon 4 lies between these two numbers. For representing the rational number, we have to form the number line according to quotient. In quotient, we have 7 upon 4, that is, denominator is 4 and it is positive. So, all numbers lies on the right hand side of 0. So, we will convert 1 into 1 upon 4, 2 into 2 upon 4, 3 into 3 upon 4 and so on. Now, P represent the value, that is 7 upon 4. Question number first, second part, minus 5 upon 6. Case second, if numerator is less than denominator, then no need to convert it into mixed fraction. For representing the rational number, we have to form the number line according to quotient. In quotient, we have minus 5 upon 6, that is negative number. So, it lies on the left side of 0. Here, denominator is 6, so we have to convert all the number with denominator 6. So, we will convert according to quotient, that is minus 1 into minus 1 upon 6, minus 2 into minus 2 upon 6, minus 3 into minus 3 upon 6 and so on. Now m represent the value, that is minus 5 upon 6. Question 2 represent minus 2 upon 11, minus 5 upon 11 and minus 9 upon 11 on the number line. In this question, we have all denominator are same and also it satisfies the case second, that means numerator is less than denominator. So, we have no need to convert into mixed fraction. We directly represent it on the number line as it is previous question. Question number 3. Write 5 rational numbers which are smaller than 2. Solution 1 upon 3, 1 upon 4, 1 upon 2, minus 1 upon 2 and minus 1 upon 5 and so on. These all numbers are smaller than 2. We also have second method to solve it. We know that in negative integers, minus 1 is the largest number. That means minus 1 is greater than minus 2, minus 3 and minus 4. But in positive integers, we will follow as the counting numbers. That is 1 is less than 2 and 2 is less than 3 and 3 is less than 4. As we know, on the left side of a particular number represent the smaller value and on the right side of a particular number represent the larger value. So, according to number line, 5 rational numbers which are smaller than 2 are 1, 0, minus 1, minus 2 and minus 3. Now, let's continue our next topic. Method of finding rational numbers between two rational numbers. Method 1. Find two rational numbers between 2 upon 5 and 3 upon 5. In this question, we have denominators are same and numerators are 2 and 3. That means we are not getting any number between 2 upon 5 and 3 upon 5. So, for solving this question, we take n equals to 2, which represent how many numbers we have to find. Then n plus 1 equals to 2 plus 1, that is equals to 3. Now multiplying the numerator and denominator by 3, then we get 2 upon 5 into 3 upon 3 is equals to 6 upon 15 and 3 into 3 divided by 5 into 3 is equals to 9 upon 15. Therefore, two rational number that lies between 2 upon 5 and 3 upon 5 are 7 upon 15 and 8 upon 15. Method 2. Find two rational numbers between 1 upon 4 and 1 upon 3. In this question, denominators are different. Firstly, we will form the same denominator. For this, we will take LCM of denominator, that is LCM of 4 and 3, that is 12. Now, we multiply 1 upon 4 by 3 and 1 by 3 by 4 because 12 divides 4 by 3 and 12 divides 3 by 4. Then we get 3 upon 12 and 4 upon 12 in which denominators are same. Now it has formed as previous question. Now for getting the two rational numbers between these two numbers, we have to multiply the numerator and denominator by 3 because here n equals to 10, which represent how many rational number we have to find. So we need to find n plus 1, that is equals to 2 plus 1 equals to 3. Then after multiplication we will get 9 upon 36 and 12 upon 36, in which many rational numbers are there, that is 10 upon 36, 11 upon 36. Therefore, two rational numbers between 1 upon 4 and 1 upon 3 are 10 upon 36 and 11 upon 36. Question 4. Find 10 rational numbers between minus 2 upon 5 and 1 upon 2. Here, denominator are different. So firstly, we will form the same denominator by taking LCM of denominator. So we will get the LCM of 5 and 2 is 10. Now we multiply minus 2 upon 5 by 2 and 1 upon 2 by 5, because 5 10 divides 5 by 2 and 10 divides 2 by 5. Now again we have to find the 10 rational numbers between minus 2 upon 5 and 1 upon 2. So we have to form according to this. Minus 4 upon 10 is multiplied by 2, then we get minus 8 upon 20. 5 upon 10 is multiplied again by 2, then we will get 10 upon 20. Then 10 rational numbers between minus 2 upon 5 and 1 upon 2 are minus 7 upon 20, minus 6 upon 20, minus 5 upon 20, minus 4 upon 20, minus 3 upon 20, minus 2 upon 20, minus 1 upon 20, 0, 1 upon 20, and 2 upon 20. Children, next two questions are related to previous question. So I am giving you as a homework. Try to solve them. Question number 7. Find 10 rational numbers between 3 upon 5 and 3 upon 4. Here denominators are same. So firstly, we will form the same denominator by taking the LCM of denominator. Therefore, LCM of 5 and 4 is 20. Now we multiply 3 upon 5 by 4 and 3 upon 4 by 5, because 20 divides 5 by 4 and 20 divides 4 by 5. But we have got only two rational number between 12 upon 20 and 15 upon 20, and we need to find 10 rational number. So we again multiply 12 upon 20 by 8 and 15 upon 20 by 8. Then we will get 96 upon 160 and 120 upon 160. Therefore, 10 rational numbers between 3 upon 5 and 3 upon 4 are 97 upon 160, 98 upon 160, 99 upon 160, 100 upon 160, 101 upon 160, 102 upon 160, 103 upon 160, 104 upon 160, 105 upon 160, and 1 upon 106 upon 160. I hope you understood